Hi guys, how are you all? Early morning, right? Hi Vishrank, I've been missing you, missing you, missing you. Can we all get started?
Okay. Okay.
Sure. Did you get to do the homework? Last test, I saw that.
Yeah, I did the homework.
Uh-huh. Okay. Did you have any questions?
Well, let me see.
Yeah. If you have any questions, let's go over that first. Because there was a lot of concepts dealt with in the last class. I really don't want to move on unless you guys are clear with. And similarly, you know what? The week 5 mock test I gave, right? It is a real mock test of 2025 provided by AOPS users. Do it, guys. I did see that you have not attempted, and it was a little bit concerning. Are you all liking to do it?
Auntie.
Yeah, go ahead. Swarit, I saw you had requested. You know, Google Forms is really good now. It tells me who are all wanting to do it. They changed something in Google Form. So now Google Form tells me whether you're wanting to do it or not. So Swarit, I saw that you wanted to do that mock, right, Swarit?
Yeah.
Yes. What happened to that?
Uh, I still didn't get access, I think. Oh,
I gave, right? Immediately I'll give. Usually within that day you get it. Whenever I see my email, I give it.
okay. And then when I just looked at the homework,
Uh-huh.
um, oh wait, I forgot where it is.
Okay. You know
The
what? You all coming on the video really helps as well. I know it's early in the morning. Take 5 minutes, but then come on the video. You take your time, but then come on the video. So that way you will also feel energized. It takes
the
a while,
first
I understand. Yeah, go ahead.
the first 6 questions on the permutations and combinations homework,
Uh-huh.
I
Was
didn't
it?
understand.
No problem. I'll go over it. Okay. First 6 questions. Vishrank, how was it for you?
I did most of the questions.
Oh, nice. Okay. Did you
I
go through the video, Vishrank?
Yeah, I went through the
Did it
video.
help you?
Yeah.
Good. How about Anika and Shrikar? Shrikar, I know you would not have gone through. Anika, how about you?
I couldn't do it because I wasn't feeling well this past week.
Oh, I am so sorry, ma. Okay, see, something is going around. So, Swarit, which one do you want to do? Let me ask Vishank to explain. Let's see. This one?
Yeah,
What?
no. The
Oh,
first 6.
yeah, yeah. See, these concepts are very new to you. Okay, but if you learn this now, right, geometry will be so easy for you guys. Geometry, one big chapter is on permutations and combinations. You'll find it so easy 2 years later. Which one did you not understand, Swarit?
Just like mostly like how they're like formatted. So like 7P3, right? For
Yeah.
example, the first one. Uh I didn't understand you would do
Correct.
that.
What is it? Oh, what to do? Oh,
Yeah.
Swarit, you
Like
not attend the class?
no. I watched the recording, but it's like I was still confused.
The recording clearly shows formulas, right?
Really? Okay.
Yeah, really. And there were notes as well. See, Swarit, notes on permutation combinations,
Uh,
permutations. See, factorial. What is the factorial? See, it's here, right? Did you see this, Swarit?
no.
N factorial by n minus r factorial. See, this is the number n, this is the number r.
So would it be 7 factorial
By
or
7 minus 4
7
factorial.
minus?
Correct. Yes.
Okay.
You got it?
Okay.
We just got an introduction to permutations combinations. I wanted to go review this now because this is a hard one and I really want you guys to get the basics of this. Can I go ahead and try? Okay. Vishrang, did you understand this?
Yeah.
Okay, let's try. Did you understand combinations, Vishrang?
Yeah, it's a bit more difficult, but like I still understand.
I see. Let's see. Simple problems can I give you and see? And then we'll go to geometry. See, I'm not going to deal with hard one today, but let's see. Let's review and make sure we are good with whatever we have learned. I've gone only to 2 set Venn diagrams. I have not gone to 3 set Venn diagrams for you guys. Okay, how about this? Let's see. Okay, this is a good one. Okay, it's still, you don't have the book. I have to, okay, I thought of arranging for the book, but let's see. Okay, let's review a few. Basic on permutation. Okay, permutation we can review as well. Let's see. From last week only. Okay, meaning I'm not going to do anything new right away now, but some part of geometric probability I'm going to cover. Geometric probability is easier, okay, than anything. Okay, so let's see. How about this? Okay. Okay, how about this? Oh, why am I not able to write, guys? Give me a minute. How many different? It's just a review problem from last week. Okay, 7-letter combinations can be made from the word algebra by rearranging it. Can you try this one?
Okay.
Go ahead and try. Simple ones, let's solve. Go ahead. There was, I wanted to give you one challenge. This one is just based out of last week, okay? But I want to give you one challenge in this. Let's see. But this does not cover all of it, okay? We are touching there and here the very basics, which is still good for you guys. Let's see. I was looking at a problem. When I saw that problem, I really wanted to come and give it to you guys. Let's see. This one is a challenge.
Miss Priya, can I use a calculator?
No. Why? Among competitions, nobody gets you a calculator, right? Meaning, let me know, meaning I don't understand your perception. So if you can explain to me, I'll be able to understand. What is it?
Like one of those simple calculators that you know, like addition, subtraction, multiplication,
Oh,
division.
no, no,
Because
no.
it's like
No, no calculator. No calculator for this one. You know why, ma? Competitions do not let you use calculators.
okay.
See, how many letters are there? Dia, I think you forgot something, Dia. I think we need to go over once more. Okay, I will slow down the class. Okay, if none of you. Wow. Harshita, did you do the homework?
Yeah.
That's interesting. Very nice. Very nice, Harshita. Wait, I don't know. I think that's the answer. Yes, correct, ma. Annika, that's not correct, ma. You want to explain, Harshita?
Okay. So because it's a 7-letter combination, it would be 7 factorial.
Mhm.
Auntie, I don't know how to write on the screen. Is that
No
fine?
problem. I can write, ma. Go ahead.
So it'll be 7 factorial, and then the word algebra has has the letter A repeating 2 times. So it'll be 2 factorial, and then L is repeating 1 time. So it'll be 1 factorial, G is repeating 1 time. So the same thing for the rest of the letters, E,
Mm-hmm.
B, R, and A. And
Mm-hmm.
then when you do the math, you get 5040 divided by 2. And when you do that, you get the answer.
Good job. So basically, in how many ways you can arrange the letters in the word algebra? For this one, guys, see, if you're given a question like how many arrangements are there for sun? How many arrangements you can make from the word sun by rearranging it? You can do S as the first letter, SUN, SNU. And then with N as the first letter, you can do US or SU. Or the last one is U as the first letter. You can have SU, I'm sorry, SN or NS. Correct, guys? So there are 6 combinations. You can't be writing this every time. So you know what you do? Okay, 3-letter word, right? There are 3 different choices, meaning this can be S or a U or a N, correct? Let's take one of these, then there are 2 options for this one. Finally, there's only one leftover letter. So you multiply all of them. So you get 3 times 2 times 1. You get it? So this is all about finding the combinations of letters. Here, each letter is unique. Y'all got it? Now, if suppose I make this sun as SNN, how many possible combinations are there? SNN is there, but you can't put another SNN. It's the same, right? Because there are 2 N's. See what happens when there are repetitions. So N can be the first letter, and then N, S, N can be. Okay, and N and S can be. And after that, again, you cannot have N as the first letter because you already had it and that's a repeat. See, now it reduces. Literally, it divides by 2. When there are 2 repetitions, it divides by 2. When there are 3 repetitions, what happens, you see? So just one combination. So from 6, it made to a 3. So when there were 2 repetitions, it was divided by 2. When there were 3 repetitions, it was divided by, see, it was divided by 2 factorial basically. Here it's divided by 3 factorial. 3 factorial means 3 duplicates. 3 factorial is 6. So 6 was divided by 6. You had only one combination. Any questions here? Similarly, let's say you have the word mob or moose. Moose vanda. Okay, let's surf. How many combinations are there? The letters can be rearranged and made into how many different letter combinations? Who can tell me that? One of you explain, guys. If you know, you
4
explain.
factorial, 4.
4 factorial, correct. Yes, because there are 4.
Which would be 24.
Yeah, four choices here, 3 choices here, 2 choices here, 1 choices here. Yes. So like that, but if there are repetitions only, you will have to divide by that factorial because the duplicates have to be removed, right? So now go ahead and do this problem for me. I really want you to understand well before we move on. So go ahead and do this problem. 7-letter word algebra. Now, how many different combinations are there? It's not a hard one. See, if we don't understand the basics, there's no point moving forward to. Doesn't matter for me. Meaning, I don't mind not finishing something that we said we will do unless you understand things. If you understand things, yes, I need to move on. I cannot wait. Go ahead and do this one. How many different 7-letter combinations can be made from the word algebra? By rearranging the letters. Here there are duplicates. That is the worst part of this. Did you guys get it? Ma, if you don't get it, this is the time to shout out. Auntie, I didn't get it. Yes, all of you got it this time, I think. Annika, can I help you, Annika? Ah, you got it. Okay. Okay, Shriyank, where is your answer? Diya, Shrikar, where is your answer?
Here's my answer.
Uh, oh yeah, Shrikar, I see your answer. Diya, what was your answer? Ma, shout it out.
2520.
Oh yeah, I got it. I got it. Shriyank, where is your answer, ma? Vishrank, I'm sorry, Vishrank. You know, I have a boy called Shriyank in the other class. Vishrank, where is your answer, ma?
Oh yeah, I need to stuff for this.
Huh?
I'm still solving it.
Oh, okay. So basically, can I go ahead and do? Okay, only thing is, Annika, I want to clarify that. Amma, you divide, if suppose two letters are repeated, you divide by 2 factorial, not just by 2. Got it? Okay.
Yes. So when
7
the
factorial by 2
letters repeat is
factorial. So 7,
so
6, 5, 4, 3, 2, 1 divided by 2. So you'll have to multiply these. How do you easily multiply these two? You know what? 5 and 2 multiplication is very powerful. Okay. So now, how do you multiply this? I will split it out as 7, 6, 5, 2, 2, 3. Okay. If I do that, 6 sevens are 42. Leave this. Okay. 42 times 6 is what? 42 times 6 can be very quick. 252. 252 times 10. 2520. You don't need calculators. Can I move on? Guys, can I move on?
Yes.
Okay. How many possible number of word arrangements are there for the word icicle? We are spending a lot of time, but that's okay. How many possible arrangements are there for the word icicle? You know what? After this, I'm going to give you a challenge, I said. I'm going to give it to you. Wait. Okay, I don't know the answer. I have to check. Go ahead, guys. Oh, wow. Very nice. Most of you got it. But is that 30 the answer? Did you calculate it properly? I don't know, guys. Let's see. Which answer is correct? I don't know now. So Shreyank, Vishrang, did you get it?
Yeah, almost.
Should I wait, Ma?
Yeah, I'll just finish it real quick.
Yeah. You know what? I really request you, I earnestly request you to be on the video. If you feel sleepy, that will go. Okay. When you see the others on screen, right, it will go. So meaning feel free to switch on the video, guys. Doesn't matter. At the end of it, we are all same, you see. So here 1, 2, 3, 4, 5, 6.
Yeah.
So this will be 6 factorial, but several are repeats. I is repeated, C is repeated. What else is repeated? 2 factorial, 2 factorial, correct? So what happens? 6, 5, 4, 3, 2, 1 divided by 2, 2. 4, 4 get cancelled. Now, please always reserve this. They are best friends, 5 and 2. Rest of it you can multiply easily. 6 threes are 18 times 10, 180. Yup, but there was one another 30 answer. What happened? Diya.
Instead of doing 2 factorial, doing 2 factorial, I
You did
placed
one of
4
them.
factorial.
Okay. I see. You bring up a good point. Oh, you did 4 factorial. Okay, 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 okay. Did you see, Ma? 2 factorial times 2 factorial is what basically? Good that you said that. So 2 factorial is 2 times 1, 2 times 1, right? So there is no 4 factorial is 4, 3, 2, 1. So 1, 3 gets extra. So don't do that. You got it?
Yeah.
Okay. Now I'm going to bring you the challenge. Okay. Um, this challenge is meant for, I don't know, it's a 4th grade question. It's given, but I didn't see any 4th grader resolving it quickly. Okay, meaning they're all missing. Okay, I gave it and saw. Seems a difficult one. Why don't you try this one? It was given in a 4th grade exam. How many different 4-digit numbers can be formed by rearranging all 4 digits of 3035? It's a tricky question. I will wait. Mhm. I have one more question for you. Okay. Did you get it, guys? Okay, Anika, I'll help you, ma'am. Um, why it is 3 factorial, Anika? Why do you think it's 3 factorial? All of you got tricked, guys. What do you mean by that?
Oh, the zero can be
Yeah,
first
but
one, so it will be a
Anika, the
digit.
repeats are just 3, right? 3 is the only number that repeats, right? Only
Yeah.
digit that repeats, right?
Yeah.
So,
Oh,
think so, right? You see what I mean? There are no 2 repeats, right? So
yeah.
can I go ahead and say something about this? You know how many ways these can be rearranged? You tell me. If I give you 4 numbers, how many, see, their question is very clever. How many different 4-digit numbers? So what is the requirement for a 4-digit number? Can it start with a 0? But when
Oh,
I rearrange it, that 0 can come as the first digit, right? Don't worry about it, okay? As long as we recognize it, it's fine. 3035. So how many ways can these be rearranged, Swarit? Shrikar, how many ways can this be rearranged? Go ahead. How many ways it can be rearranged? How many possibilities for this first digit?
3.
Pain.
Or
You want to do 3, yeah? Okay.
because of the
Okay.
0.
Okay. Okay. Then for the second digit, how many possibilities?
3,
Uh-huh. For the
and
third
then
digit?
2, and then 1.
Good. So there are
18.
18
And then there's
divided by the duplicate
2
factorial. How many are
divided by
repeated?
2.
2 factorial, right? So what is the answer?
B.
9. See how tricky they have given. Everybody got the answer as 12. It's okay because see, I gave the same problem to a set of fourth, fifth graders. Okay, they all, everybody has it. They are into competitive math. Okay, they all said the answer is 12, but you have to recognize that 0 cannot become here. So you have to do every step of it. Okay, so if I form a 4-digit number, what are the possibilities in here? Only 3, this, or this. Okay, we will avoid the duplicates later. Did you get it, guys? Okay, now another challenge coming your way. It's not a challenge. I didn't teach you the principle of complementary counting. Okay, there is a principle of complementary counting. But without knowing it, let's see whether you're able to crack this. Okay, this is also a test question. Let's see. Oh, what is that? Okay, I'm only reviewing, guys. I'm not teaching anything new, I feel, but that's okay. Let's make sure we get it. A math team of 3 students is selected from a group of 5. In how many ways this selection can be made? The problem is that constraint there. Andrew and Carol cannot be in the same team. Okay, let me frame this a little differently. Okay, meaning I have not taught you complementary counting. Complementary means the other way. Complementary counting, right? Okay, let's see. I'll show you. This question itself involves complementary counting. What do you do in complementary counting? They have given a constraint, right? Cannot be in the other team. I'll reframe it. Okay. In how many ways? I'll reframe the question. In how many ways? See whether you can do this. If you can do this, you can do that. In how many ways this selection can be made? Answer this question, then that becomes easy. Can be made if Andrew and Carol are in the same team. Is that easy? That is very easy, I tell you, because you're going to choose 3 people only from 5. So find out the possibilities for each of the positions. Here, the order is not important. If the order is not important, you don't have to go with permutation. You have to go with combination. So order is not important. Anybody can be anywhere because it's a team that you're going to choose. So for each of that, if you can write out how many choices are there automatically, but please remember Andrew and Carol are in the same team. They are chosen and they are in the same team. So that makes it so easy. somebody wants to share their thoughts, even if it is wrong, please feel free to, guys. Then only that confidence will come. And if you do this right, whether believe it or not, leave alone AMC8. Geometry, a whole chapter is on combinations and permutations. Good job, Harshita. Did you understand nicely, ma?
Yeah, I understand what you.
So, okay, you got the answer for the question I asked. Now, can you go ahead and solve the first one?
Okay.
So, whatever you have given should be removed, right?
Yes.
So you have a total number of combinations, okay? For 5 people, for 3 people to be picked out from the 5, okay? That is that's very easy to count. In that, you have to remove this number of combinations because you don't want them to be in the same team. Am I making sense, Arshita?
I think so. I think you
I'll
did.
explain to each of you based on your understanding. Vishrang, can you explain how did you say that answer? Explain, ma. I'll help you, I'm saying. Go ahead.
Because there's like 3 possibilities for the first
For the
one.
first one,
Yeah.
why do you think there's a 3 possibility?
Because it's Andrew Carroll and there can only be one other person, so there's 3.
Okay. Can I say something about this, about your thought, Vishank? You are saying Andrew and Carol have to be in the team. So they are not options. They are must. A and C are a must. You get it, huh? Whether it is C and A or A and C, they are a must. You got it? So there is only one choice for this, one choice for this. Don't you think so? Order is not important. If you choose Andrew here, Carol here, Andrew here. It's combinations, okay? So it is one only. You got it? They have to be in the team. But for the last one, how many choices are there?
1. Well, wait. No. None.
Why? In a math team of 3 students is selected from a group of 5. Good job, Dia.
There can only be one extra person because it's a
Yeah, there
math.
can be only one extra person, okay? That extra person, how many choices for that person is there? Swarit, correct.
3.
3.
Because
Good job. Yeah. So the total number of possible combination for selecting a team of 3 from 5 kids where Andrew and Carol are a part of the team is just 3 possibilities. You got it? Now the question is the opposite. See, this is how you solve. Question is the opposite. So that is what is complementary counting. You find out something you don't need at all. See, they are asking in how many ways can you select a team of 3 from 5 where Andrew and Carol cannot be in the same team. But what you're calculating? I'm calculating Andrew and Carol in the same team. So that is 3. 3 ways Andrew and Carol can be in the team. Right? Now, what you can do is subtract that. See, here, how many total possibilities are there to pick out 3 people? Be it any 3 people, don't worry about it. Be it any 3 people, if you want to pick out, it is 5 choose 3. Right? So what is that? 5 factorial by 2 factorial, 3 factorial. That is the formula, right? This is the total number of ways you can choose 3 people from 5 people, which is 5. Let me write it down. 5, 4, 3, 2, 1 by 3, 2, 2. So score of the 4, score of the 3, answer is 10 ways. You have 10 ways to choose 3 people from a group of 5. In that 10 ways, I don't want these 3. So what happens? Did you get it, guys? Did you get it?
okay, so you subtract by 3, then you get 7.
Yeah, you subtract the 3. Am I making sense?
Yeah.
So this is what is complementary counting. You found out what is not required and subtract it from the original.
Wait, so is it 10 or 7?
You tell me, Swarit.
I'm
No,
confused.
I want you to understand, right? At the end, it's okay. Even if you make a mistake, I'm here to help. 10 or
I'm
7.
confused, that's why.
Huh?
I'm confused.
For this,
Like,
the answer was 3.
yeah, I know that, but like
Okay,
9
now,
plus
yeah, meaning
5
just to pick
factorial
out
over
3,
2.
3 people from a group of 5, it was 10 ways. But what is asked in how many ways the selection can be made? If they both cannot be in the same team. So what will be the answer? This 10, remove the 3. 7 ways. You all got it?
Yeah.
Initially it's difficult, but what would solve more problem, you get the hang of it. Did you all try solving alchemist? Did you try solving alchemist? You know, as a part of this class, you know what I do? I don't leave it to you to do, okay? I sit with my daughter and whatever topics I give you, I work with her. Okay, then I feel how hard it is. Yes, she's also a first timer. So when she does it, she finds it very hard. But sometimes when solving that alchemist, figuring out really helps. First 5 problems is very hard. And after that, 6 problems she solves and so happy. So try it out. Did you try alchemist, guys? Okay, in that, Vishrank, are you aware of that?
No.
I did tell in the video, right, Vishrank? Okay, let me see. So here, do you see? Meaning,
Yeah.
I don't leave it to you as it is, okay? Every
Oh,
time
wait.
I also try and do. Meaning, it's not that I do personally, but at least I try it with someone, whoever is available, or something I do so that I am aware of how hard it is for you guys. Now, let me show you.
Oh, yeah, wait. I saw this.
Yeah, so go to resources. This is a treasure, guys. Go to resources, go to alchemist. Okay. Can you all do one thing? Can we try this one? Meaning it is a little hard, okay, but let's see. Uh, we will do some playing now, okay? Here, when you go, change the focus, okay? Don't see mine, okay? It's all in red. I would not have attempted anything, okay? So here, when you go to counting probability, go to counting probability. See, we have done this, counting numbers and lists. Venn diagrams I have taught you. Factorials I have taught you. Permutations I have taught you. It's not that I've taught fully, okay, honestly. Casework counting, complementary count. Complementary counting is what we just dealt with one example. So these all you can do. Basically, basic combinations you can do. Basic combinations and basic probabilities counting you can do. See, all these topics, if you go do some problem, it's totally different. Okay, it is a little hard, but then once you get a hang of it, it's easy. You want to try basic combinations? Let's see. See, in how many ways can 13 students be selected from a group of 15 to serve on a chalkboard cleaning team? Who can, it's a mental question. Tell me. Tell me, guys. No, 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 you don't need to find out the answer. What is the answer? 15 combined 13. Oh, yeah. They're asking you to find out. What is the answer, guys? Ma, shout out, ma. It's okay to be wrong. Let's count it together. I'm not asking, hey, do you know? Do you know? I'm not judging anything. Tell something. How do we calculate this? 15 factorial by
15 minus 3 or 13. 2 factorial.
factorial and 2 factorial, right? Because 15C13, right? 15 factorial, n factorial by n minus r factorial and r factorial, because you have to remove the duplicates, right? So
Yeah.
here it is n minus r factorial is 2 factorial and then r factorial. You got
Yeah.
it? Now the thing is, this is 15, 14, 13 factorial, right? Denominator will be 13 factorial and 2 factorial. 13 and 13 factorial will get cancelled. The 2 factorial is 7. So answer is 15 times 7. Can we try 105 and see? I thought they'll accept the combinations answer. You get it, guys? It's correct. So confidence builds in only when you try, and it's okay to go wrong. Okay, don't give up. Try the 2 times, don't give up. How about this? I won a trip for 4 to a Super Bowl. I can bring 3 of my friends. I can bring 3 of my friends. I have 8 friends. In how many ways can I form my Super Bowl party? I won a trip for 4 to the Super Bowl. I can bring, why is he saying I can bring only 3 of my friends? What does
Because
it?
Because he has to
because
take
he
himself.
also
Yeah,
he's
correct.
also
Very
going.
nice, very nice. He has to go. So, oh my gosh. So what happens? Do you want to give it a try? Go ahead and try, guys. Your foundational math will be so much improved when you do all these alchemist problems every week when we try. The target is not just like that, hey, to attempt AMC8 and become and get a 20 or 20. No, that's not the target. Okay, what did we learn? Did we improve in our math foundations? Yes, right? So that really counts. You won't realize it now. After 1 or 2 years, you'll realize it doesn't matter to me. Go ahead. Yeah, and the mock exam, please do, guys. That is a mock exam. The test number 5 was a mock 2025 AMC8 mock. Okay, for that, the answers are not yet even out. They have not put out the answers for the mock. I just gave you thinking that we can submit our answers and get the answers. Usually, they release the answers only when we submit it. They will tell the scores. They won't, meaning it's not yet out. They release it only on January 12th. So that mock I gave you. So please attempt it. Okay, I sincerely do take the effort and give you, oh, this is a good one for these kids. Like that, I prepare the test. Go ahead. Definitely attempt that test. I'm not going to give you a new test. For those of you who completed only, I'm going to send. Did you do? Can I enter the answers, guys? What answer? What answer should I enter? Anika says 7, 3, 3, 3. What should I enter? Somebody shout out. Guys, what do you want me to enter? 3 is the most answer. Okay, that seems wrong. Oh, I see. That was the previous answer. Okay, then please send. Anika got 6. Okay, others? I have to work it out and see, guys. I'm going to wait and see. Anika, do you want to explain how you got 6? Harshita,
I'm
yet.
not sure. I just did a bunch of random stuff.
Lemma, how did you? I feel that comfortable, Shrikar. That answer is comfortable to me. You want to explain that, Shrikar? Harshita, what did you get? Vishrang, try Amma. It's okay to go wrong.
I'm still solving the problem.
Okay. It comes with practice. 10 problems you'll make mistakes in these. Counting probability is a tough nut to crack. But once you get it, it will be easy. Okay. So I'll give you clues. I won a trip for 4. Okay. He's included. So he has to only choose 3. Okay. But he has 8 friends. So there are 8 people. Okay. He has to choose 3. What should you do? Order does matter. It doesn't matter at all. Whether I choose Andrew A, B, C or C, A, B doesn't matter. So you can go with combinations. If order doesn't matter, you can go ahead with combinations. So you will have to do 8 choose 3. What will you do? 8 factorial by 3 factorial, 8 minus 3 factorial. What is that? 8 factorial by 3 factorial, then 5 factorial. How do you solve this? 8, 7, 6, 5, 4, 3, 2, divide by 3, 2, 5, 4, 3. Now, what can I cancel? 5, 4, 3 is cancelled. 3, 2 is cancelled. What remains? Something feels wrong. I got 86, but now why? 6, 5, 4, 3. 5, 4, 3 is cancelled. 6 is cancelled. Good. Okay. 5, 4, 3, 2, and then a 6 is cancelled. Oh, 5 factorial is 5, 4, 3, 2, right? I forgot that. Now, Annika, illema, how it is 104, ma? Annika, 8 factorial divided by 5 factorial is what? 8 factorial is nothing but 8, 7, 6, and then a 5 factorial. Denominator has 5 factorial and 3 factorial. These two get cancelled. After that, 3 factorial is 6. This will get cancelled. So answer is just 56. Vishrank, did you get? You got it. Okay. So let's see. Got it, guys? Okay, similarly, you know what you should do, basic combinations you can try, okay? Your target should be to get a 99 here. There is a 28 here, right? You should take it to a 99. 99, not even 98. Similarly, go for factorials. That's the basic actually. Factorials is the basic. Can you do this for me? I'll do it for you. How do you do this? 11 factorial divide by 9 factorial plus 2 times 8 factorial. Now, it's a little tricky, okay? Here there is a plus, right? So see what is common between both the expressions. This is an expression, this is an expression, right? What is common between the two? Who can tell me what is common between the two? You have to apply distributive property. What is common between the two? What are the numbers that are common?
Factorials.
Yeah, factorial, ma. But what numbers are common? If you expand it, what numbers will be common?
8 factorial.
Good. 8 factorial is common. Both the terms have 8 factorial in it. When I take that 8 factorial out, what remains in the first term?
9.
Good. 9 remains. And in the next term, what remains? You took 8 factorial out. 2. Good job. So the numerator had 11 factorial. 11 and 8 factorial can be cancelled. So what will remain in the numerator?
4, 10, and 11.
What is it, ma? Tell, right? I will help. I'm here to help.
10 times 10 times 9.
Yeah, so basically 11 factorial is 11, 9, 8, 7, 6, 5, 4, 3, 2, right? 8 factorial is what? 8, 7, 6, 5, 4, 3, 2. Cancel that off. You get it? Now what remains? 11, 10, I forgot.
990.
Yeah, don't do that. Don't multiply. Unless it is required, don't multiply in competitive maths. Okay. So write it down. 11, 10, 9. Denominator is 11. See? It will reduce the pain. Answer is 90. You got it, guys?
Okay.
Get it? So this is 90. See? Do you want to do one more problem? We are just reviewing last week. Okay, right now I'm just reviewing last week. At least geometric probability I want to cover today. Okay, this one is the last one. Come on, guys, quick. Rest of it, please try at home. For you to get the trigger, I'm doing it now. Try that one. Wow, good job, guys. You all got it. Diya, Shrikar, Annika, correct. Hey, are you getting meaning learning something new, guys? Okay. These again come in geometry for you, but AMC8 it's really helpful. But AMC8 requires a stretch. You see what I mean? Meaning a lot more in depth. This is not yet enough. But unless we learn the basics, we can't go into depth as well. Let's see. Shrikar, Annika, Diya, correct. Can I get the answers from the others? Swarit and Vishank, I'm waiting for you. I don't want to wait too much, but at the same time, I want to give the turn. Harshita, did you get it, ma?
Yeah, let me submit my answer.
Please send, ma. Whatever you get, send. Vishank, send, ma. Okay, let me see if I can bring something in geometric probability, because if I don't teach anything new, I'll also not feel good about it. One second, guys. One second, guys. One second, guys. Yeah, go ahead. We have Santa coming on the round in our community for the kids. Go ahead. Harshita, correct, ma. Vishram, can I help you?
I'm still solving it.
Yeah, I'll wait. No problem. No hurrying. Okay. Who else? Is anybody else not getting? Please let me know, guys. I don't want to pick at the same time. Shout out. Yes, Swarit, I'll help you. What is that?
Right.
Swarit, I'll help you. Go ahead.
So,
Where are you stuck?
so 3 times 5 factorial plus 15 times 4 factorial, right? Wouldn't the common term be like 4 factorial?
Correct. Good job. See?
But then
Applying
how
this
would I
to-
reform that is my
I'll help you. Yeah. Take out the 4 factorial. Okay. Come to the first term. Okay. In this, what is there? You tell me. Write this term with a 4 factorial. 3 times 4 factorial times 5. Can I write it like that?
Yeah.
So now if you take out the 4 factorial, what remains for it?
3 times 5.
Correct. What is that?
15
15. And then you have the plus.
plus
Now
15.
what? Uh-huh.
And
Then
then
divide,
what's
divide by 6
divided
factorial.
by
Correct?
6?
Now what do you do, Swarit?
Uh,
4 factorial.
do you distribute it?
Yeah, you already distributed,
Uh,
right? Now work on the parenthesis. 15 plus 15 is what?
30.
30. Divide by
6 factorial.
6 factorial. So what happens here? Can I write this in terms of 4 factorial?
Yeah.
4 factorial times
Oh,
5 times 6, correct?
yeah.
Can I
Four,
disregard?
yeah, and then 5 times 6 is 30.
So what is the answer?
1.
1. Good job. That's it. Easy?
Yeah.
Okay. It comes. I promise. When you do the homework, you'll not be it will not be this difficult. See? Ah. That's okay. You want to do or can I move on? I don't know how to do this. Do you want to do this one or move on? Let's try. What is the units digit of the sum? 1 factorial is 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4, 3, 2, 1. It moves on. So 1000 factorial is what? 1000 times 999 times 9. This is crazy. So something should be easy somewhere. You tell me, guys. You have to think. Nobody will want you, particularly in competitive math, where you have to say the answer in a second. Nobody will want you to break your head. What should be the answer for this one? Good job, Dia. It's not a hard one. Simply they are trying to get you off the track. Think about you're going to add so many numbers. But there should be an easy way out. When you think about just the units digit, okay, which will be the highest number? Yes, correct, Anika. But why? Come on, think. You're right. But I'm glad that you're telling you feel like it. But why? So this will be the highest number, right? And it goes on till 1, goes on multiplying. You know, in mathematics, this multiplication by 10, 100, thousands, they are so prominent and so important. When you multiply any number here, there will be a lot of tens, a lot of hundreds, a lot of 1, 800, 900, so many things are going to be there. So what should be the units digit of that number? When you multiply by a 10, the unit digit is always 0. When you multiply by 100, unit digit is always 0. When you multiply by 1000, unit digit is always 0. When you multiply by 800, unit digit is again 0. You are going to get so many zeros at the end. So what will be the units digit? Come on, guys. 0, right? Ah, that's wrong. Oh my gosh. I thought it's 0. Wait, wait, wait. What did we do? 1000 factorial. I thought it's 0, honestly. But what is the units digit of the sum? Okay. Oh, of the sum. Oh my gosh. Okay, of the sum. Okay. Sorry. So, what is going to contribute to the units digit? There'll be a lot of zeros in here, but the problem is what is going to contribute to the units digit? This 1, this 2 factorial is 2, 3 factorial is 6. Those are going to change that 0, right? Because of these, because of all of this, whatever be your units digit, right? It's going to change. So 4 factorial is 4 3s are 12. 12 2s are 24. Okay. 24. Okay. Whatever be your units, let's find it. 5 4 3 2 1. 5 4 3 2 1. So in this case, 20 times 6, 120. Okay. So that moves on. 6 factorial means times 6, right? So that is going to be 0 again. So all this will be 0. But what will change it? So all this is going to contribute zeros. So 6 factorial will end up in a 0, right? 7 factorial is also going to end up in a 0. Everything will end up in a 0. See, that's where I got deceived. But then these are not going to be zeros. So these two will end up in a 0. So what will be the units digit? Come on. You think it's a 2, Anika? Why? I feel it's a 3 too.
Yeah.
Yeah, I was so much deceived looking at the last. Yes, we are right. Good job. So basically the leftmost values will play importance. You know why? Because everything will be a 0 on the rightmost, right? So I just saw that and typed in a 0, but I did not look at this 1 factorial, 2 factorial. Those are going to change the units digit, right? So would you be able to take care of this further, guys? Can I move on? Okay, so go to change focus and you're going to do more problems. Okay, let me go to a little bit in geometric probability. This one is a good different problem, but this is not to the level of AMC8. Let's see. I have a rectangular plot. This is not to the level of AMC8, but this is a good one to know before you get going. I have a rectangular plot of land that is 60 yards long and 30 yards wide. Okay. If I place a fence post, if I place a fence post on each corner, if I place a fence post on each corner, okay, and posts are placed every 3 yards. It's a tricky question. Every 3 yards, but just counting. How many fence posts are there in?
Auntie, Auntie, I have to leave now.
Sure, ma.
Bye.
Yeah, go ahead, ma. Are there in each side? We'll try this one. I have a rectangular plot of land that is 60 yards long, 30 yards wide. If I place a fence post on each corner, 30, 60, right? If I, that is 60 yards long, 30 yards wide, okay. How many fence posts will there be on each side? Can I help or you want to try, guys? Please let me know. Can I try or you want to try? Would you mind looking at Pascal triangle and coming back next week? Next class, tomorrow, can you research on Pascal's triangles and come back? We do everything in class. I feel like it will take a lot of time as well. Let's see. If you can just Google out Pascal triangle, it will be so helpful. Try, guys. See, do you all know how to plot linear equations in a graph? Do you all know how to plot linear equations in a graph? Linear inequality in a graph. Y greater than x minus 4. Do you know how to plot it in a graph? Swarit, you don't know? Okay, no problem. Do you know how to plot this y equal to x minus 4 in a graph?
Yeah.
Vishrang knows. Swarit knows? Hmm?
Thinks I know.
Okay, let's see. Let's see. Let's see. Go ahead, guys. Did you get it? So can I go ahead and do, or you want to do this one? How many posts are there? This is a little tricky question, auntie. Okay. Can I do it for you guys? I have a rectangular plot of land that is 60 yards long. So fence post is kept at every 3 yards. That means what? There. Then after that 3 yards, right? Meaning if you keep it 3 yards apart, right? So what happens here? 3 yards apart means how many posts will be there? 60. 60 when you divide it by 3 yards, right? How many posts will be there?
20.
Huh?
20.
20 posts will be there. But basically, see, you have in two corners, right? So what happens? You have it in two corners, right?
If if you have it in two corners,
Go ahead.
uh,
You see what I mean?
plus
Huh?
2 or minus 2?
Okay, let's see. Okay, I'm going to count only this 20, right? Because the corner one has to get added. I'm not going to add it. Now on this side, if it is 30 yards, right? It'll be again 30 divided by 3, 10 plus 1, 11, but I'm going to count only 10. You got it?
Yeah.
The corners I'm not going to count and going to count in the next one. So now this corner I counted. So from here, the corner one I'm not going to count on this because I already counted here. So here again, it's going to be 20. This I'm going to include, this corner. Okay, now this corner I did not include, so that will be a 10 and not 11. So how many posts are there? Do you see? 20, 20, 40, 50, 60 posts.
Wait, but then it says how many fence posts are there on each side?
Yeah, totally there are 60, so 20 and 10. You got it?
Okay.
So total is 60 posts. Here what happens is everybody makes a mistake of not counting the corners. Basically, a 60 yards long, 60 yards long and you're posting 3 yard wide post means totally in this line, right? There will be 20 plus 1. You got it? 20 plus 1 post will be there. Here 11 posts will be there. But the corners you're accounting for only one time. That's why it becomes 20 and 10. Make sense? Make sense? Okay. So see, the homework for this week will be on counting basics, and I'm going to share the book with you. Okay. Counting basics and Venn diagrams, we did it last time. I'm going to give you Venn diagrams, but 3-set Venn diagrams, I'm going to keep away from 3-set Venn diagrams. Okay. 3-set Venn diagrams are a little hard for now. Okay. And let's say another question. Suppose if there are three people, in a room, okay, each gives handshake to the other. Each gives a handshake to the other. How many handshakes are possible? How many distinct handshakes are possible? Distinct means I giving you is the same as you giving me. How many distinct handshakes are possible? Try, guys. Go ahead. Go ahead, Amma. So good. This is good. See, you're all using factorials. I'm happy about. So the first person, right, will have how many handshakes? There are three people, A, B, C. So basically, A is going to give to B, C, right? So that is 2 handshakes. And then B is going to give, he cannot give it to A, he can only give it to C. C already gave, so 2 plus 1. So it is 2 factorial here. Do you get it, guys? How many handshakes are possible? I'm sorry, 2 plus 1 is 3. So basically it is, here it is 2 plus 1, answer is 3. Okay. Now, suppose if there are 5 people in a room, 5 people in a room, how many handshakes are possible? How do you do it?
Is it distinct?
Yeah, how many distinct handshakes? So A can give to B, C, D, E. Okay, when you think about it, so it starts with a 4. 4 plus 3 plus 2 plus 1. B can give it to C, D, E. C can give it to D, E. E can't give, D can give still to E. So it is 4 plus 3 plus 2 plus 1. Do you get it? So what is this 4 plus 3 plus 2 plus 1? Do you know how to calculate this? Not like this, 7, 8, 9, 10. Don't say 10 is easy. Okay. Suppose there are 1 or 2 people in a room. How many handshakes? How many handshakes? It will start with what number? The first person can give to how many other people?
101 other people.
Yes, it starts with 101, then 100, then 99, 98, 97. It goes on till 1. How do you add all of these? Anybody? How do you add all of these?
101.
101 and 1 make 102. 102 make 100.
Correct. That is a good way to do. But you know what? Sum of n numbers. Sum of n numbers. How do you do? Sum of first n numbers.
101 plus 1, and then 100 plus 2,
Correct.
and then
Correct. So go ahead with n times n plus 1 by 2. That gives you the sum. Here it is 101 is the last number, right? 101 times 102 divided by 2. So this will be 51. 101 times 51 is your answer. You got it, guys? 5151 handshakes. See, this is a very, very quickie formula, which is a very basic one that we use for competitive math again. To find the sum of n numbers, this is used in pre-cal. At your school level, they bring it up in pre-cal. Pre-calculus, when you study, that time, see, who has done competitive math, you'll all know already. If you have not done, everything will be new in pre-cal. Did you guys get it now? Did you guys get this? Why it is n times n plus 1 by 2? I wanted to watch a video. I don't know how much I'll show, but let's see. Let's see if I have the video ready. Okay. Carl Eric Goss. I want the video. Where is the video? Addition. There was. This one. I really want you guys to see the video. Can I share the video? With this, we'll conclude. This one. This is the exact video I want you to see. It's a 3-minute video I want you to see.
Do you sometimes feel that your math
Are
class
you-
is intentionally just boring busy work?
Are you able to hear, guys? Okay.
Then check out this story from the mathematician Karl Gauss. In 1787, young Karl was a 10-year-old student in Braunschweig, Germany. His school was especially dismal, with dark, low-ceiling classrooms and abusive teachers. There was a teacher at the school named Buttner. Although Buttner enjoyed intimidating his students, he found that a long day of teaching required too much work. Therefore, he would give his students interminable, tedious tasks to keep them all busy, so he was able to relax. As the story goes, on one occasion he gave his class the assignment to add together all the numbers between 1 and 100. He presumed this would afford him a relaxing afternoon of watching students tap away at their slates. However, he had barely finished his instructions when his student, the young Karl Gauss, stood up from his desk, walked to the front of the class, and turned in his slate on Buttner's large desk with an offhanded, "There you go."
Hey, have you seen this video already? Oh, you should, guys. It's a very interesting one.
Young Karl sat quietly for the rest of the afternoon while the other students finished their addition. And Buttner planned how he would beat his arrogant student for avoiding his classwork. One by one, the other students turned in their slates on top of Karl's. When they had all been turned in, Butner ripped out Carl's slate from the bottom to see what nonsense he had submitted. To his astonishment, he saw Carl had the correct answer, and the only number on the slate was the answer. He had written no calculations whatsoever. How did he do it? How could he avoid such boring, repetitive work and still get the right answer? It's not certain exactly what approach Gauss used, but with the speed at which he solved it, he probably thought along these lines. Consider the numbers 1 through 100 drawn out end to end, with 1 on one side and 100 on the other.
Anika, this is exactly what you said, right?
If we add the first and last number in the sequence, 1 plus 100, we get 101. If we move in one step to 2 and 99 and add those together, you again get 101. Moving in one more step to 3 and 98, those also total 101. The pattern continues throughout the entire sequence of numbers until we meet at the exact center at 50 plus 51 equaling 101. To get a better look at this relationship, let's encode these numbers as little squares, starting with a single square, a stack of 2 squares, and 3 squares, and so on, growing up in a sort of staircase shape to the tallest stack of 100 squares. Butner's addition task now becomes simply counting up the total number of squares in this shape. We can make this staircase shape easier to measure by splitting it along the middle between 50 and 51 and fitting the pieces together to form a rectangle. We're adding numbers
Do you get it, guys? See how fascinating math is.
to make 101 a total of 50 times, giving us a rectangle with the width of 50 squares and a height of 101 squares. The total number of squares is 50 times 101, which is 5,050. So there you go. This pattern can work to add together any sequence of numbers. So let's look for a general description of this pattern. The height of the rectangle is the sum of the first and last numbers. The width of the rectangle is the total number of digits being added, divided in half. The area of the rectangle is these two values multiplied together. We can continue to build on this basic pattern and see the big takeaway from all this in part 2. So follow me and check out the comments for.
Did you get it, guys? This is a wonderful one. Okay. So I'll post this. I'll post this for you in Google Classroom as well. Okay. So again, for this week, right, we have just worked on, again, counting principles, a little bit of complementary counting, not even probability. Okay. So I'm going to give more questions on this so that you get a nice picture of what is basic counting, complementary counting. Casework counting means, see, you have to arrange case by case and then do counting. So let's try one. With that, I'll let you go. Okay, let's try one last question and then I'll let you go. It's regarding dices. So let me see. 1 minute. Let's do one more and then I'll let you go, guys. I don't want complementary counting. Pascal's triangle. Then yeah, why don't we do this? Casework. Let's see this. This is the last question, okay? So let's see this one. We are already over time, but that's okay. Let's see this one. How about this? Okay, I'm rolling a die 3 times. I roll a die 3 times. Okay. What is the probability? Probability means it should be a fraction between 0 and 1. What is the probability that the third roll is greater than the sum of first 2 rolls? Is greater than the sum of first 2 rolls. I will do it for you, but you can give me your thoughts. I roll a die 3 times. So roll 1, roll 2, roll 3. what is the probability that the third roll is greater than the sum of first two rolls, right? So here the thing is there can be a few cases. What can the cases be? The roll number 3 can be what? What are the cases? Case 1, case 2. This is case work counting, meaning you group them into cases. Okay, the third roll is a 6. The third roll can be a 5. The third roll can be a 4. The third roll can be a 3. Can the third roll be a 2?
Yeah.
Uh,
Cause it's one. If you roll one, if roll 1 and roll 2 are ones, then
yeah, but the third roll is
oh
greater.
no, it's greater, right? Okay.
So only 4 cases are there. Case 1, case 2. You will analyze. This is the hardest part of case work counting. Sometimes we tend to miss cases. Okay, it's so important. Now, case 1. If it has a 6, right? What can the first two rolls be? Come on, guys, quick. What can be the possibilities? 1, comma 1. Then roll 1, roll 2. What can it be?
1, 2,
1, 2. Then
1, 3,
1, 3,
good. 1, 3.
1, 4,
1,
1,
4.
4.
That's
1,
it.
4,
But
Then
2,
there's 2
2, 1.
3,
2, 1
2, 2,
and
2,
2,
2.
2,
2,
2,
2,
3.
3,
that, and
Uh,
then 3,
3,
1,
2, 3,
3,
1,
1.
2,
3,
Start with the
2,
1. 3, 2.
and
3,
then
3
4,
can't be
1.
there.
4,
4, 1.
1,
Then what else? 4, 2
Uh,
can't be there, right?
no,
Yeah.
I
So how
think
many
it's
possible? So how this gives you how many possibilities?
10.
1, 2, 3, 4, 5. 10. Good job. Next one. Do quickly, ma. 5. 1, 1.
1,
1,
1,
1, 1,
2,
2, 1, 3,
1, 3,
1,
2,
2.
1,
1,
2,
3.
1,
2,
2, 2,
3,
and
1,
3,
1, 4 as well possible, right? 1, 4 not possible. 2, 1. 2, 2. 2, 3.
3,
2, 3 is not
3,
possible.
no,
3, 1,
3, 1.
and then
2 is not
that's
possible.
it.
yeah, that's
4,
it.
1 is yeah, not possible. 1, 2, 3, 4, 5, 6. See, case for counting is a pain. Next, go ahead.
1, 1, 1, 2,
1, 1.
So
It's easy.
what
It'll
is
come
it?
up quickly. 1, 1.
1, 1, 1, 2,
1, 2. 1, 3 is not possible. 2, 1 is
3,
possible.
1.
Yes. 2, 2 is not possible. 3, 1 is not possible. Okay,
Yeah.
3. Then the case 4. 1, 1.
1, 1,
That's all I feel,
Yeah,
right?
that's it.
yeah.
Yeah.
1 is not possible. Yeah, 1. So how many total cases are there? 10, 16,
20,
20.
20. Okay. So now, okay, when you roll a die 3 times, how many possibilities are there? See, how many possibilities are there? How many choices do we have? We can have 6 here, 6 here, 6 here, right, guys?
6 cubed.
Yeah, 6 cubes. So
196.
196 are 36 times 6,
Wait, no.
216, right?
Oops, sorry.
So
216.
what is the simplified form of this? 10 divided by 108, 5 divided by 54. So the probability is 5 by 54.
54.
Make sense? Make sense, Vishrang, did you get it?
Yeah.
See, doing it like this by working out cases, and each case you need to work out what is the number of possibilities. So each work has got counting to it. You see, it's more complicated where you sort out by cases, and for each case you have to work probability or whatever combinations you'll have to work out. So then you get to add all of these. This is called case work counting. You sort by cases and then work out for each case. Okay, so I'll give you simple problems on these topics: basic counting, casework counting, factorials. Like that, we'll do simple problems for this week once more. So we are a little solid on that basics. Make sense?
Okay.
Okay, guys. Any questions for me? Please attempt test 5.
Okay.
Okay, what else? Shall we disperse?
Yeah.
Okay, guys. See you all next week. No, tomorrow morning we have class.
Oh,
Oh, you don't like it? Sorry.
that's
Yeah,
fine.
in the morning it's like that's
It's
fine.
hard. I
Yeah.
don't mind. You guys want it in the evening? I am fine. Actually, evenings work better for me. But yeah, I don't want to
Can
change.
we make it? Can we make it like not like that early in the morning, but like around like.
Amma, then I really want you guys to initiate the conversation because I'm done coordinating because it's very difficult to get consent from every one of you. You get it, huh? Because I think Dia has some class. That's why she had to leave.
Okay.
Okay, we'll have it tomorrow, and after that, I'm fine with whatever change. Just for tomorrow, we have already agreed on. All the parents have agreed on. But after that, if you want a change, I'm all open. In tomorrow's class, let's discuss and make sure, and then we'll finalize. Okay, let's not change it for tomorrow. Make sense?
Okay.
Honestly, it's difficult for me in the morning as well, but I am okay, guys. As long as it works for everybody, I'm flexible. Okay. So tomorrow we'll see again. Bye, guys.
Bye.
Bye, guys. See you tomorrow.
Bye.
Bye.